So welcome everybody to this latest A-level video on 162 Maths, and in this video we'll be continuing with partial fractions, but this time we'll be focusing on three linear functions in the denominator of your partial fraction. Now if you completely utterly understood the first video where we looked at two linear functions in the denominator, then three linear functions in the denominator is going to be relatively quite straightforward. And if you're looking at this first, I certainly would recommend watching that video first before watching this one. Now this method is used when you have a cubic which is already often factorized for you as a denominator and either a quadratic, a linear function or a constant in the numerator. Now again, just to go over what I mean by that is that your denominator should always involve a cubic expression which can be factorized for this method taking place. So here you can see in this example here, this is our linear function. And here is our constant. That's what a constant looks like. And here we've got a quadratic. And that should be as your numerator. Now in your denominator you will have a cubic expression. Again, either that's factorized. Now if you have three, don't class this as as four functions, even though you've got four things being multiplied together. So we've got 1, 2, 3, 4. It's still three linear things involving x functions in there, and obviously here we've got another cubic expression done as well. Now in terms of the method is virtually exactly the same. However, because you've got an extra bracket, just means you're going to end up with an extra sort of step to do, an extra letter for you to then work out. And again, the method is pretty much exactly the same, but I do like having a set method when working through these types of questions, just so you know. And obviously it helps break down what you get marks for when going forward. So the first one is to break the denominator up so each bracket has the same denominator, and label the numerators A, B and C, and also make that equal to the original fraction. The second one is then to multiply both sides by the original denominator, so you lose the aspect of fractions, and then you're substituting values of x and make the bracket equal to 0, and then finding the respective A, B, C, repeat until you've got all three values, and then the final step is then substituting your A, B, C values back into step 1 so you've got your final answer. Now the best way of going through this is actually going through a question. So now I'm not going to break this up into individual steps, because obviously if you've watched the first video, then those 4 steps should make clear understanding about what it is you've actually got to do. So in terms of this particular question, which isn't really written correctly because it's stating the values of A and B, what I'm going to do is I'm just going to write down what they all equal. Now as is classed as an identity, I'm going to write it as A over the first bracket, which is x plus 1, plus B over x plus 2, plus C over x plus 3. Now again, even though I'm writing pluses in between those fractions, I don't know if they're going to be plus, so if A, B or C are negative, then obviously that will affect the sign going forward. So that would be my first step. So let me just put a little asterisk in there, step 1. Now step 2, what I need to do is just simply multiply both sides by these 3 brackets. So what we end up with is 6x squared plus 23x plus 19 equals, and it's going to be A with the other 2 brackets, because obviously that bracket, well, let's just write it down anyway. So I've got A over x plus 1, and then I've got x plus 1, x plus 2, x plus 3, plus B over x plus 2 times x plus 1, x plus 2, x plus 3, and I've got plus C over x plus 3 times x plus 1, x plus 2, and x plus 3. Now from these you'll have things that cancel out, so that cancels with that, that cancels with that, and that cancels with that, leaving with my line. Now again, you could easily go straight to the answer. So here we've got, or not the answer, but part of the next step. So I've got 23x plus 19 equals, and then it's going to be A of x plus 2, x plus 3, plus B, x plus 1, x plus 3, and C, which is x plus 1, x plus 2. So in other words, you're just taking on the other denominators. So from this, what we then need to do is find the values of x that makes each of the brackets equal to 0. So that would make it equal to 0 when x equals minus 2, and that would be 0 when x equals minus 3, and that will be 0 when x equals minus 1. So they're my 3 values that I'm going to be substituting. So to start this off, let's just move this up. So when x equals -1 start off with, then what I end up with on the left hand side, I end up with 6 take away 23 plus 19 equals, and it's going to be a that doesn't disappear because anything with +1 will disappear. So I got a lots of, and then it's going to be 1 and 2. So simplifying the left hand side, I get 2 equals 2a. So therefore a equals 2. And then moving on to the next value, so let's go for when x equals -2, then what I end up with is 24 minus 46 plus 19 equals, and it's going to be b that doesn't disappear, and so I've got -1 and 1. So simplifying the left, I get -3 and I get minus b, so therefore b equals 3. And then finishing this off with the third value, so when x equals -3, everything's going to disappear apart from the c, but I end up with 54 minus 69 plus 19 equals c, and it's going to be -2 minus 1, which then leaves me with 4 equals 2c, so therefore c equals 2. And then so all I've then got to do is return back to the original equation. So let me just zoom out so I can actually see what the original question was. So my final answer is going to be 6x squared plus 23x plus 19 over x plus 1, x plus 2, x plus 3. And that's going to be equivalent to a, which is 2 over x plus 1, plus 3 over x plus 2, plus 2 over x plus 3. And there is my final answer. And just to zoom in and to make it a bit easier, there we go. There is my final answer. So let's have a look at another example. So with this next example, again, I'm going to go straight into working my ABC. So I've got a over x minus 2 plus b 2x plus 1 plus c over x plus 2. Again, moving straight on to the second step, what I've got is I've got 7x squared plus 2x minus 12 equals, and it's going to be a with the other two denominators, so 2x plus 1 and x plus 2, plus b with the other two denominators, so x minus 2, x plus 2, and plus c with the other two denominators, which is x minus 2, 2x plus 1. So now all I've got to do now is figure out what values I'm going to be substituting in. So to make this bracket equal to 0, x needs to equal a half. For this one, it's going to be -2, and this one, it's going to be +2. So they're the three values I'm going to be substituting in. So when x equals -1/2, then what I end up with is 7, and a half squared is a quarter, and positive quarter, plus 2 times -1/2, which is -1, minus 12. And that's going to be equal to, and then which one's going to disappear? Well, everything apart from b is going to disappear. So I've got b, and then substituting x equals -1/2 in there, I get -2.5 and 1.5. I could work with fractions, so again I've got a mixture of fractions and decimals. It doesn't really make a difference because we're just working with, I'm just going to get my calculator. So I've got 11.25 minus 11.25 equals -3.75b. So therefore b equals. Moving on with the next one, I get, let's go for yellow. So when x equals -2, then what I end up with is 28 minus 4 minus 12 equals, and it's c that I'm going to keep. So c lots of -4 minus 3, which leaves me with 12 equals 12c, so c equals 1. And then finally, when x equals 2, I end up with 28 plus 4 minus 12 equals, and keep a, which is 5, 4. So simplifying this, I get 20 equals 20a, so therefore a equals 1. And they're my three values. So from this, all I then need to do is write down the final answer, in which what I get is my final answer is it's going to be 1 over x minus 2 plus b, which is 3, over 2x plus 1. Careful of the brackets. And plus c, which is 1 over x plus 2. And there is my final answer, which really I should put over here. So let's look at our third example. So with our third example here, you can see that although I've got 3 brackets, this counts as 1. So what this is going to be equal to is a over x plus b over x minus 1 plus c over 3x plus 4. So multiplying out the denominator, or not multiplying out, so moving the denominator over to the other side, end up with minus 5x squared plus 19x minus 16 equals a lots of the other two denominators plus b lots of the other denominators plus c lots of the other denominators. And there we go. So from this, the next thing we then need to do is find our values that we're going to be substituting. So make this bracket equal to 0, x needs to equal 1. Make this bracket equal to 0, x needs to equal minus 4 over 3. And to make this bracket equal to 0, x needs to equal 0. So starting off with my values, when x equals 0, I've got minus 5x, which is going to be minus 16 in terms of simplifying it. Then I've got a minus 1 minus 4. So I've got minus 16 equals 4a. So a equals minus 4. First negative, which is not a bad thing. So then when x equals positive 1, so the easy ones first, we end up with minus 5 plus 19 minus 16 equals b lots of 1 minus 1. So simplifying that, I get minus 2 equals minus b, so b equals 2. And then finally for c, when x equals minus 4 over 3, then end up with 4 over 9. I'm just going to just jump ahead. 4 over 9c, so c equals 1. My final answer then would be where equals, and it's going to be a, which is minus 4 over x. Oh, let's just write that a little bit neater. So I've got minus 4 over x plus 2 over x minus 1 plus 1 over 3x plus 4. Now alternately, because in maths they don't like things starting with a negative, what I'm going to do is you could easily move that over. So I could write this as 2 over x minus 1 plus 1 over 3x plus 4 minus 4 over x. Now both of them are the exact same answer, it's just written in a different order, and the reason for doing that is because I don't like things starting with a negative because they can easily be missed off. So where it's impossible to do that, you do that, but here again just be aware of that sometimes answers can be written slightly different, but yours is still correct. So let's move on to our last example. Now in this last example you can see 2 brackets of face value, but one thing you should spot is that this is a difference of 2 squares. So this actually is going to be 7x squared plus 4x minus 21 all over, it's going to be x plus 1, x minus 1, and then x minus 2. So just be aware that sometimes, although it looks like it's got 2 brackets, actually this got 3. And I'm then going to write this as a over x plus 1 plus b over x minus 1 plus c over x minus 2. So multiplying by the denominator, what we end up with is 7x squared plus 4x minus 21 equals, and it's going to be a with the other 2 denominators plus b with the other 2 denominators, say for c. And there we go. So again, next thing we need to do is find the values that we're going to substitute in. So I've got x equals 1, x equals 2, and x equals minus 1. So looking at our first value, so when x equals 1, what do I end up with? Well, I end up with 7 plus 4 minus 21 equals, and it's going to leave me with b, so that's 2 plus 1. So simplifying this, I get minus 10 equals minus 2b, so b equals 5. So that's my first value. The second value is when x equals 2, so that's going to give me with 28 plus 8 minus 21 equals c, which is going to keep, so that's 3 and 1. Simplifying this gives me 15 equals 3c, so therefore c equals 5 as well. And then finally, for the next one, when x is minus 1, then what I end up with is 7 minus 4 minus 21 equals a, which I keep, which is minus 2 minus 3, which is minus 18 equals 6a, so a equals minus 3. So finishing off this question, what I end up with is, in terms of final answer, let's do it in yellow, so final answer is 7x squared plus 4x minus 21 over x squared minus 1 x minus 2 equals, and it's going to be minus 3 over x plus 1 plus 5 over x minus 1 plus 5 over x minus 2. And again, or you could write it as shuffle the fractions around, so you're not starting off with a negative. As long as the numerator is correct, everyone should be happy, and there are your final answers.